Welcome to another deep dive. Today we're cutting through the buzz and hype around machine learning, or ML.
Yeah, there's a lot of it.
There really is. It's a term that gets thrown around so much, almost casually, but our mission today is to truly understand when and where ML is actually the precise tool you should reach for.
Right.
We want to equip you to make really smart decisions, or maybe just gain some crystal clear clarity on a topic that's incredibly relevant pretty much everywhere now. Okay, let's unpack this.
That's a really critical starting point because, look, while machine learning is undeniably powerful, I mean, the headlines make it sound like a magic bullet, right?
Totally.
But it's crucial to remember that it isn't. It's actually remarkably easy to get swept up in the excitement and, try to apply ML everywhere.
Yeah, I've seen that happen.
And that often leads to wasted resources, frustrating dead ends, or maybe even worse, solutions that just don't deliver. So our goal here, I think, is to give you a practical framework, a clearer lens, maybe, to help identify those truly ideal ML applications and, just as important, spot where it's absolutely not the best fit. Understanding its core suitability criteria, well, that's key to avoiding those pitfalls and actually achieving some real measurable impact.
Okay, so let's talk about that sweet spot, those conditions where ML genuinely excels. What kind of problems are we really talking about here? Is there like a specific type of challenge ML was built for?
Yeah, definitely. At its heart, ML is best for tasks that require discovery of patterns or relationships.
Discovery, finding things you didn't expect.
Exactly, finding hidden connections in data, not just, retrieving fixed information. Think of it this way. If your solution can be perfectly defined by explicit, hard-coded rules.
Like if-then statements.
Right, like a simple lookup table, say mapping zip codes to states. If you can do that easily, then ML is almost certainly overkill.
Right, don't need a sledgehammer for a thumbtack.
Precisely. It truly shines when the underlying patterns are intricate, really difficult, maybe even impossible for us humans to manually write down as rules.
Okay, give me an example.
Okay, predicting house prices. You've got dozens, sometimes hundreds of factors interacting: square footage, location, schools, recent sales, crime rates, transport links, even subtle things about the neighborhood.
Lots of moving parts.
Exactly. That kind of complexity where how things interact isn't simple or linear and you can't easily write if this, then that, that's where ML really shows its value.
So it's about that nuanced complexity that human logic kind of struggles to map out explicitly. Okay, that makes a lot of sense. What other characteristics define these ideal ML problems?
Well, fundamentally, ML excels at what we call predictive or approximation tasks.
Prediction, okay, like forecasting.
Yeah, its core value is making estimations. Could be about the future, like predicting next quarter's sales. Could be the present, like spotting a dodgy transaction right now, or even estimating something in the past that's hard to measure directly. It's designed to approximate complex calculations and generate outputs for new, unseen inputs based on the patterns it learned from old data. So if your task didn't involve some kind of prediction or estimation, if it's purely deterministic,
like 2 + 2 always equals 4.
Exactly, then ML probably isn't the right tool. You're trying to fit a square peg in a round hole, really.
That distinction, deterministic versus probabilistic, is really helpful. But, okay, none of this magic happens without the right ingredients, right? I'm thinking about data.
Ah, yes. Data.
How critical is data, and what kind of data are we talking about? Is it enough if someone just says, oh, we have tons of data?
Yeah, you've hit on maybe the most critical point. Machine learning simply cannot learn without data. It's the fuel. It's absolutely essential to have sufficient historical or collectible data that is, and this is key, directly related to the problem you're trying to solve.
Directly related, okay.
Without that foundation, the models have literally nothing to train on. They can't find patterns, they can't make predictions. Now, about your point, tons of data. It's not just about volume, it needs to be relevant and ideally clean.
Right, garbage in, garbage out.
Precisely. Think of trying to teach someone to drive a car by showing them 1,000 pictures of bicycles. You have quantity, but it's useless, right?
Yeah.
Now, it's true, there are advanced techniques for low data situations like zero shot or continual learning, but even those still rely on some data foundation to build on or transfer knowledge from. They don't start from absolutely nothing.
So it's not just any data, but the right data and enough of it. And that brings up an interesting point. What about how that data behaves over time? Does the past always need to perfectly predict the future for ML?
That's a fantastic question, and it highlights a really crucial assumption for ML success. The idea that future data will, broadly speaking, resemble past data. The patterns a model learns from history are only useful if the new data it sees in the real world, in production, follows similar underlying distributions. ML really struggles with drastic, unforeseen shifts.
Like?
Well, the classic recent example. Using pre-pandemic data to predict post-pandemic consumer behavior without adapting the model. That would lead to completely inaccurate results because the underlying patterns of life just fundamentally changed.
Yeah, that makes total sense.
It's like teaching a model to recognize an apple, then suddenly expecting it to identify a pineapple without any new training. You need ongoing monitoring and often retraining.
So definitely not a set and forget it thing if the world shifts under its feet.
Got it. And what about the frequency of these patterns within the data? Does ML like repetition?
It absolutely does. Most current ML algorithms learn best when the examples of the patterns they need to recognize show up frequently in the data.
Like practicing for a test. Exactly like that. The more times you see a type of problem, the better you get. So, tasks involving many similar instances are way better suited for ML than, say, highly unique one-off problems. If there isn't much repetition for the algorithm to learn from, well, it struggles, predicting something that happens once every 5 years. Much harder than predicting something that happens thousands of times a day.
Right. This brings us neatly into the real-world stuff. We've talked technical suitability, data, but let's zoom out. What does this mean for a business or just anyone trying to use ML practically? What are the strategic edges or maybe the trade-offs?
Yeah, this is where you balance the wow factor with practicality. One key thing is tolerating imperfections.
Imperfections, meaning it's not always right.
Exactly. ML is often probabilistic. It's most viable when the cost of a wrong prediction is relatively low, or at least manageable. Think about a product recommendation. If it suggests something you don't like, it's a minor annoyance, right?
Yeah, no big deal.
But contrast that with, say, a medical diagnosis. An error there could be catastrophic. Or critical safety systems, like in a self-driving car. In those high-stakes areas, ML needs incredibly rigorous safeguards, lots of human oversight, and a clear analysis that the benefits really outweigh the risks of even small errors. It forces you to ask, what's the acceptable margin of error for your specific problem?
That's a really important distinction. The stakes define the approach. What about scale? Is ML always worth the investment for smaller jobs?
That's vital too. The significant upfront investment for ML data prep, infrastructure, finding skilled people, it's usually best justified when the solution will be used a lot.
So volume matters.
Big time. Making vast numbers of predictions, handling huge amounts of data, automating decisions across a large scale, that's where the benefits really add up. Think fraud detection for a huge bank versus a simple rule for a small local shop. If you only need a few predictions a day, a simpler, maybe even manual system is almost certainly cheaper and faster. The benefits just don't outweigh the cost for low volume stuff.
So it's about getting enough bang for your buck from that initial setup cost.
Okay. And what about situations where things are always changing, dynamic markets, that kind of thing?
Well, that's actually where ML can have a real strategic edge. It's particularly good for situations where the patterns themselves evolve over time.
Yeah.
Think about spotting new kinds of financial fraud, or analyzing fast-changing fashion trends, or even just understanding how language shifts on social media. ML models can be retrained or updated with new data. That makes them way more adaptable than trying to constantly maintain brittle, hard-coded rules that break every time something new pops up.
Right, constantly patching rules sounds like a nightmare.
It can be. The cost of keeping a rule-based system up to date in a really dynamic environment can easily get bigger than the cost of retraining an ML model periodically.
That's a great point about adaptability. But okay, let's flip the coin. We know when it shines. When is ML actually a poor fit? When should we just, pump the brakes?
Knowing when not to use it is just as critical. First off, and this is huge, ethical concerns.
If the application raises significant ethical issues, potential for unfair bias, major privacy violations, maybe manipulation, then ML should be avoided, or at least approached with extreme caution. You need robust ethical frameworks baked in from the start. This isn't just technical, it's about responsibility.
A critical line in the sand. What if a problem just isn't that complex?
Exactly. If a much simpler, cheaper, more reliable non-ML solution works perfectly well, maybe a basic rule-based system, a simple lookup table, even just basic stats, then using ML is just adding unnecessary complexity.
Don't over-engineer it.
Please don't. The goal should be solving the problem efficiently, not just using the shiniest new tool. Sometimes the simplest solution is the most elegant.
And finally, the practical side. The bottom line, cost.
Absolutely. If the total cost, development, data, infrastructure, maintenance, and the potential cost of errors outweigh the expected benefits, then ML just isn't a sound business decision.
Seems obvious, but...
But many projects fall into this trap. You really need a thorough, honest cost-benefit analysis before you start, not when you're already deep in it.
Right. So it sounds like it's not always all or nothing, though. Are there nuances? Maybe ML fits into a part of a problem.
Absolutely. It's rarely black and white. A key nuance is problem decomposition.
Breaking it down.
Exactly. Even if ML can't solve the whole end-to-end problem, it might be fantastic for specific subparts. Like maybe ML classifies a customer email's intent before it gets routed to the right department instead of trying to automate the whole conversation.
Ah, okay. Use it for a specific task within a bigger flow.
Precisely. Or identifying patterns in medical scans to help a doctor diagnose, rather than making the diagnosis itself. It doesn't have to be the whole answer to be valuable.
That's a smart approach. And what about looking ahead? Is there ever a time to invest in ML, even if it's not strictly cost-effective today? A strategic play.
That brings us to strategic investment. Yes, sometimes. While immediate cost-effectiveness is usually key, just dismissing a promising ML application because it's not as efficient as old methods right now can be really short-sighted.
Like early tech adoption.
Think about the early days of self-driving cars. Zero immediate ROI, huge long-term potential. Investing early in emerging ML areas, especially in new fields, can give you a big competitive edge later as the tech matures. But
There's always a but.
right, this isn't a blank check. It needs careful strategic justification beyond just hoping for the best. It's about genuinely anticipating future shifts and positioning yourself.
That's a really insightful distinction. Okay, so to kind of wrap this up for you, our listener, machine learning.
Yeah.
It's powerful, it's specialized, but it's not a universal fix.
Definitely not.
It's mainly for those complex, data-rich, predictive problems that need to operate at scale. Problems where patterns exist but are maybe too tricky to write down manually, where those patterns might change, and crucially, where the cost of an imperfect prediction is acceptable, or at least manageable.
Exactly right. It's not a cure-all. You should always deploy it thoughtfully. Always check if simpler alternatives work first, and always consider the ethical and economic side for your specific situation.
Makes sense.
So maybe as you go about your day, think about a problem you're facing, something you want to optimize or understand. Based on what we've talked about, could ML really be the right fit? Or would a simpler approach actually be more effective? What new questions does this raise for you about where technology truly belongs?
Excellent questions to ponder, and I hope this framework helps you find some answers. Thank you so much for joining us on this deep dive. We hope this helps you keep asking those insightful questions about the tech shaping our world. Until next time.